So our next speaker. No, that wasn't what I meant. Just hit the magic button at the bottom. No, it's not the bottom.
Your screen is the one there. The bottom.
How am I going? There we go. Sorry, Chair. So next is J.R. Zhang talking about analysis at the CSNS.
Okay, thanks, Peter. Actually, I work on the data analysis for China simulation neutron source, but today I will not focus on the specific data analysis. Actually, this year we just started the upgrade project for CSNS that's named CSNS2. So after 5 years operation with CSNS, we are thinking build or redesign data analysis architecture to satisfy the requirement from instrument and the users. So today I'd like to share what we are thinking and how and the way, the roadmap to the CSNS2 data analysis software. Okay, today it's happy to sit here and ESF and NL gives a very great example for a combination of the neutron and the synchrotron. And the China simulation source, well, we also follow the convention to create enhance the combination of the two facilities. So besides the China simulation source, sorry, that's a low reference, we want actually just next month we will propose a South Advanced Photon source. So we hope it will be approved next year. So probably it will take us another 6 years to build a photon source just beside the China simulation source. Of course, our institute still have a new synchrotron in Beijing. Our college, I believe some college will talk about that. The brightness synchrotron will be open for users next year. So we are lovely to see several synchrotron and neutron facility in our institute. So this year, the notebooks come back to ESF LL. So I wish the notebooks will go to the new facility and the future facility to enhance the communication between facilities. Okay, today I really like to say the word notebooks is always my university. Yeah, we benefited from the conference and learn our project and also use the existing software to our data analysis. So that's the timeline for our data analysis group of China simulation source. You can see that 2013 we just kick off for CSNS. That time we attended NOBAC 10. Since that we learned and benefit from the NOBAC conference. And 2018 CSS just is open for users. As I said before, after several years of the operation, we have some lesson to force us to change in CSS2. So that's this year, Novax 14 that gives some new idea and some things to share for CSS2. In 2029, we will have CSS2. Probably we also will have the synchrotron beside the CSNS. So we have to prepare the CSS2 also the synchrotron. So that's what we have to think about. Okay, this is about the CSS2. Initially in CSS1 we just have 11 neutron beam lines, and in CSS2 we will have the proton and also proton station, and also 2 muon SR. So that's challenges for us. In CSS, with just limited number of the neutron instrument, but in CSS2 we will have some new type of neutron instrument, and also proton, and muon, and probably the time is quite harsh for us. We'll build a neutron and a synchrotron in the same time. So we have to think about the architecture for the software and data analysis, including neutron, proton, muon, and synchrotron. That's what we have to do. So today, as I said, I want to share what the roadmap or just some consideration how to rebuild our software for the coming CSN2 and also the photon source in the CSN site. So we really suffer for that. So today I'd like to share what we have experienced. Of course, all the facility has a similar experience, but here I'd like to share what the different for CSNS. So the left figure shows the user beam time for users in last year. It's crazy. So, the beam time for users is more than 5,400. The problem is for CSNS, the data analysis group have to be involved the instrument, not only software. So we have to contribute our home source to carry out the experiment, even the data analysis for the user program. So that means all the home source is always limited for the data analysis. So initially we want to provide more functions to the instrumentation, but finally we have to be reality. We have to consider the low maintenance. That's what we focus on so far. Okay, this is what I do in CSNS. We have to carry out data management, software, and also today this section, data reduction and analysis. Also, we take care of the Monte simulation and DFT and MD simulation too. So as I say, actually, initially, before running, before operation with CSNS, the group is named software. But finally, we have to remove to the data analysis. This is the normal formal name of the group, because, as I said, in CSS, the situation is quite different. We cannot just play as engineering. We have to kind of be scientists, because the beam scientists really don't want to understand what's going on in the low level. Of course, my background is condensed matter physics, but I have to say, I hope there's no scientist here today. So yeah, always fighting with the beam scientists. Because beam scientists just want the result. They never care about what happened, and so we have to be involved all the things: software reduction, even commissioning of the instrument, and also data analysis for each proposal. So that's really complicated to continue our works. So that's what I think. I think kind of I'm degenerated, because initially we want to provide many fancy functions or full function for each instrumentation, but finally we have to think about how to reduce the maintenance cost. So this is what's the design of the data analysis for each instrumentation. As I said before, during the commissioning or even the operation, the data analysis group have to play as the role of the detective. We have to find out or do some troubleshoot for each instrument. The beam scientist always said there's no data or data is wrong. So next, the question is what caused the problem? So now actually that should be the things of a beam scientist, but in CSNS they hand over to data analysis or software group. That's ridiculous. So, but we have two. So the design of the data analysis for CSNS instrument is initially we want to have a very smart, strong brain to control each component. So we want to know what happened at each component. That's ideal. But finally, it caused many problems because the brain is never smart enough. So that means we have to reduce that to keep high reliability. Of course, we did many plan B, plan C, plan D, but it never works. Well, yeah, of course, I think every facility have to do the device diagnostic issue alarm, but it never works. So finally, we have to think to rebuild our software structure. That means we have to remove the brain. We have to ask each component work independently to keep it. But surprisingly, it works very well. So that's what we have to create or design the data analysis software. I will will not tell the details. That's what show what we have to make efforts on that. Next is here shows the reliability story. Reliability of the facility is quite high. So we have to debug all the time because the beam scientists don't care what time it is, even we are in the deep sleep or on holiday. They will call us to debug or do something. They think we are capable to fix that in hours, not in days, in weeks. So in CSNS, at least in my group, we have to do like that. No IDEs, as Peter asked, what IDE we use, but we have to reduce or remove the IDE because we have to access the software anytime, anywhere to debug, to keep it going running. And the number of experiments increased largely. Initially, we think about to provide more API, more APP to support the data analysis. But finally, we realized the number of the computer resource is always a problem, so we couldn't provide enough. So of course, this is a data modeling simulation. The user can access our cloud system. They don't have to do anything. They can access cloud without download data, without upgrade software. I don't want to tell the details. But finally, we realized the computer resource is always limited, and so finally we will go the roadmap to use the web as a way, trying to realize all this data analysis use the web. So far we have worked on the reduction and analysis as a service. Okay, another one is this is the layout of the instrument because of course but the software should be solid, but finally we realized the flexibility is more important. So this is the left side is our design for the data analysis. We use the factory pattern. Because in first several years it run very solid. I so love the design, but with the increasing of the number, the instrument they ask us to increase the function and give a more fancy function. So it's quite limited. It's really headache. So we have to move to the microservice design to satisfy the flexibility development. Of course, this is outdated. We have moved to the other design. And I will come to last slides. I guess it's perfect. Okay, another thing that I have to tell is so far probably most users still use the fitting to data fitting for their data. So we have, but for neutron guys, probably well about this, the hydrogen current sample or multi-scattering of its limitation for the usage of neutron scattering. So we developed the all cross-section based Monte Carlo simulation to promote, and it's very successful. It can simulate, give the result of the coherent, incoherent, elastic scattering, and also it can reproduce the neutron experiment very lovely. And we will deploy all the simulation code to the each instrument. And also we just build a CSNS AI workshop, work group. We have to, of course, to be honest, I do not understand the AI at all, not at all, but I have to know how to use that. So we just build the work group to promote the AI usage for the data analysis of neutron scattering. That's what we are moving on. And also big facility has a big data, but problem is how to get all the information and how to know the information is right or full. So we have to collect the sample information, analyze data, and the structure and the properties related to sample in order to for the data analysis. So before we tried several ways to collect or spy the information, but never succeeded because we trying to change our data policy or trying to argue with the user community, but never succeeded to collect all the data. So, but our college should promote some way to use a large language model to try to collect and filter the data to try to promote the database and also AI. Okay, I will not list or repeat what I said. Okay, I will close my practice here. Okay, thanks.
I will say you're among friends. Unfortunately, there are scientists here. In the interest of time, I am going to forego questions.
I would like to
so please reach out to JR. His email is in the conference. Thank you.
Okay.